So coming to our today's class, in the last class we started with prescriptive process models. So right, yeah, I'm sharing my screen. In the last class we started with prescriptive process models. This is what we saw in the last class. We saw a brief review of this process models. We started with waterfall model initially. So coming to this prescriptive models, the name is given as prescriptive. Why? Because it is going to prescribe all the process elements that are going to flow within the process. So the process elements include all the framework activities, all the actions, tasks, work products, and all the umbrella activities like quality assurance, change control management. So all these elements will be included within the process, and that is being prescribed by these models. So that is the reason we call them as prescriptive models. In that prescriptive models, you will be having first category as linear models. In the linear models, water flow model comes into category 1. Right, waterfall model comes into linear model. Why? Because if you see the diagram, you can understand the flow of the activities is linear or sequential. So for that reason, it comes under linear model. So, yes, tell me.
Ma'am, అది నెంబర్ 11 కి సిగ్నల్ ప్రాబ్లం ఉండి కనెక్ట్ అవ్వట్లేదు మ్యామ్. అంత అస్మాన్ రీకనెక్ట్ అవుతున్నాను మ్యామ్, అందు గురించే కనెక్ట్ అవ్వలేదు.
అంటే తను ఆడియో కనెక్ట్ అవుతున్నాడు, ఆడియో కనెక్ట్ అవ్వట్లేదు, కానీ వీడియో మాత్రం ఆన్ లో పెట్టుకుంటున్నాడు. అంటే హి ఇస్ నాట్ లిసనింగ్ టు క్లాస్, జస్ట్ ఆన్ చేసేసి వదిలేస్తున్నాడు కంప్యూటర్ ఆడియో. ఓకే, తనకి ఫోన్ చేశారా?
అంటే ఇప్పుడు ఫోన్ చేస్తే ఇట్లా చెప్పాడు మ్యామ్ నాకు.
ఓకే, తన్ని క్లాస్
ఫోన్ చేస్తే ఇట్లా చెప్పాడు మ్యామ్ నాకు. అంటే
ఓకే, క్లాస్ అయిపోయాక తన్ని నాకు కాల్ చేయమని చెప్పండి తర్వాత. ఓకే, యూ కంటిన్యూ విత్ ద క్లాస్, తర్వాత మీరు.
ఓకే మ్యామ్. ఓకే.
So coming to this waterfall model, this is the basic model, that process model that was developed. So also called as a classic life cycle model, right? So this waterfall model, it follows a systematic sequential approach. Systematic in the sense an orderly approach, and sequential is one after the another, right? So it starts with, this waterfall model starts with customer specification and requirements and ends with deployment. As the 5 framework activities will be common in all the process models, it starts with communication and ends with deployment. So right, students, I already told you, when you are asked to write about any process model, please explain all the activities first. Please explain the 5 activities first and then start with this model in detail, right? So in this model, you explain all these 5 activities, which we already saw in the previous class. And particularly coming to this waterfall model, the water as the model, the process flow will be sequential. So after completing the first phase, then only you can move on to the second phase, and next the third phase, and so on. So there is no way for you to go iterate back and make any changes if necessary. So that is the main disadvantage of this waterfall model. So when will we use this waterfall model is in the context where the requirements are reasonably well understood. If the client is able to tell you all the requirements in the initial stage itself, then only you can go for the waterfall model. And this waterfall model, it will be apted only if the project is of smaller project, right? If for larger products, this waterfall model will not be suited. Why? Because in larger projects, the requirement will not be fixed. They keep on changing. If there are any changing requirements, waterfall model cannot accommodate, right? So this model will be suitable only if you are asked to develop much smaller projects. And particularly the main constraint is all the requirements should be given by the client in the initial stage itself. Then only you can go for this waterfall model. And next, coming to these advantages, as we already told you, it is simple and easy to understand. Right, this is the first model, and it is the simple model when compared to the rest of the models. And the next one is, this model does not have any overlapping phases, in the sense 2 or 3 phases will not be done parallelly. Only the phases will be developed one after the another. So overlapping phases will not be present. That is an advantage. And next, it can serve in the situations where requirements are fixed and the work is proceeded to complete in a linear manner. So we can use this model only when the requirements are fixed, right? So these are all the advantages of a waterfall model. And coming to the disadvantages, this will not be suitable for risky projects or real life projects. Why? Because in real life projects, the requirements will be changed. They will not be fixed, right? So this waterfall model will not be useful for present generation projects or real life projects, right? It will not be accommodating risky features. And one more disadvantage is the customer needs to wait until the end for long time to know what has been developed actually. See, if you notice this model, so initially you are having some communication with the client, with the customer, and next this planning, modeling, construction, all these things are done by the developer. In this phases there is no sort of involvement with the customer, right? Only the developers will be doing all these things, and finally the customer will get the deployed project at the end. In the sense, he will be able to communicate in the initial phase, and finally only he will be involved in the project. In the sense, he will be deliver the product. In the middle phases, he will not be knowing where the project is, and he should have some patience to wait until the end of the project. So that is what we are saying here. The customer should have some patience, right? And the working version of the programs will not be available until late in the project time zone. So by the end only, the product will be delivered to the customer. And another main problem is problems remain uncovered till software testing. Say if you are having a problem in this communication phase, you gathered wrong requirements, you made an error in this communication phase, the same error will be continued according to these requirements only. Will go on with the planning. The same error is carried on to the next phase, and the same error will be carried on in the designing, and finally the coding part. In testing, you will be able to identify the error you have made. So right here only we'll get the result of the testing. So in this intermediate phases, in the beginning phases, there is no chance for us to know what are all the errors that we have made. So that can be told as one of the drawback in waterfall model. Problems remain uncovered still software testing. Only in the testing phase we will be able to identify the errors. Until then, there is no chance for us to know the errors. So these are the advantages and disadvantages of waterfall model. And next, coming to another model in linear process models, next is the V model. So right students, when we move from one model to another model, definitely there will be some disadvantages in the previous model, which we'll be trying to rectify them in the next models, right? Now in V model, why did we come from waterfall model to V model is because of this last point. So here we told that problems remain uncovered till software testing. So the test case, in the testing, what we generally do is after writing the code, we prepare some test cases here. See, for suppose you wrote you will be using your Gmail accounts, right? In Gmail, while you are entering your data, mail ID and password, some test cases are working on there. For example, while giving a password, you will be given some conditions that your password should contain one uppercase letter, one lowercase letter, one special symbol. So all these are different test cases, right? If you for suppose if you give all the uppercase letter which is not prescribed in the instruction, then you will get an error message. In the sense, the test case has been failed and you are getting an error message there. So right, all these will be test cases which we'll be seeing in detail in next classes. So what we mean to say here is, after the coding part, the test cases will be written by the developer. In the sense, I'm checking whether my code is working correctly or not in all the constraints, in all the situations. For login page, you are asked to, we'll write some test cases to check whether if you are giving an authorized username and password, whether you are able to log in or not. If you are giving some unauthorized username, you should not be able to. So all these will be checked here. So the test cases will be written in this testing phase and testing will be done here. So in V model, we come particularly from waterfall to V model. Why? Because the main reason is V model is based on association of testing phase for each corresponding developing phase. First of all, what does this V stands for is, V stands for verification and validation. See, if you see the model, you will be having a V symbol, right? So this half part is called as verification phase, and the rest of the part is called as validation phase. Both together they'll resemble an alphabet V. That is reason we call this as a V model. So why did we come from waterfall model to V model? Because In waterfall model, test cases, test planning is done at the end. Whereas in V model, after the development of every phase, after the completion of every phase, the test planning will be done parallelly. That is the reason we came from waterfall to V model. See, remember, I'm saying that you're not testing, but test planning is done parallelly. So what should be tested, what test cases should be tested finally, all those test cases planning will be done in the each phase itself. So that is the reason we came from waterfall model to V model. See here, we are calling verification and validation. There is a slight difference between verification and validation, even though both the terms seems to be same, but there will be a slight difference between verification and validation. For example, if you are asked to go for a new place, for example, your mother asked you to, your parents asked you to go to Hyderabad, right? Which is a very new place, which is your project. Think that that is your project. You are asked to go to your Hyderabad by the client, your parents. Here the clients are your parents. Now you are doing your project for the first time. You definitely you will plan. You will be planning how to go to Hyderabad, right? That planning, maybe you will be using your Google map, or you will take some assistance. You'll ask your friend to say the route map or how to go to that area, right? So while traveling, you're starting from Eluru. While traveling, you travel until Vijayawada. You'll check whether you travel according to the route map or not. So in the sense, you're verifying whether you're going in the proper way or not. And after reaching Vijayawada, from there you'll go to some other place and check whether you're traveling in the exact route or not, right? So intermediately you're checking whether the content you have developed until that phase is as per the plan or not, as per the previous guidelines or not. So this you will be calling it as verification. So during the development, you are checking whether you're developing the product right or not. That is called as verification. And what does validation means is, once you go on to the dead end, once you have reached the Hyderabad, you will finally check whether the customer need is satisfied or not. Here the customer is your parents. Your parents asked you to go to Hyderabad, right? And finally, after reaching the destination, you are checking whether the customer need is satisfied or not. Whether you have finally reached as per your parents or not. So that is called as validation. So there is a difference between verification and validation. Verification is done in development phase. You are checking whether the product you have been developed is developing right or not in the intermediate. And validation is done after the development, after the coding. Here you will be checking whether you have developed the product right or not. Here you are developing right or not, and here you are checking whether the developed product is right or not as per the client requirements, as per the user requirements. So that is called as verification and validation. See, coming to this V model, you are having the 5 framework activities that is common. So in this left part, you are having the requirements gathering, modeling, and code generation. In the right part, you are having the testing and deployment phase. Here deployment is not shown here, only different categories of testings are written here, right? So here you are having requirements, designing, and code generation phases, and next you are having testing phases on the other end. So coming to this phase, starting with requirement modeling, you know what you will be doing here. You will be communicating with the client when gathering all the requirements, analyzing all those requirements, and you will prepare a document called software requirement specification document here. So right, this software requirement specification document contains all the functionalities that should be included, all the details that should be included in our project. Which software, which hardware you are using, what are the modules that you are going to develop, what are the platforms you are going, which environment, what are the process, what are the protocols you are going to use. So all these will be included in this software requirement specification documents, right? Which include functional requirements and non-functional requirements, which we'll be seeing later. For example, functional requirements will be, for example, if you are asked to develop a car, consider any hardware industry. If you are asked to manufacture a car, develop a car, in that the functional requirements will be, the car should perform basically some functions, right? The car should run on the road. it should stop when you're giving a break, right? It should have some speed limits. These are all the basic functional requirements, right? The functionality of that product. And non-functional requirements is there is in order to perform all the functions, some background activities, some non-functional requirements should be included. For example, if you are asked to develop a car, there is no one who will be saying you that the car should be of this shape. See, standardly we are having a shape of a car as fixed, right? If you are developing a car, that model should not be resembling some aeroplane kind of thing. The model should be, the car model will be same for all the cars unless and until slight differences, but overall the model will be looking the same. That is a non-functional thing. For suppose if you are asked to develop a car, there will be no one saying you that the car should have 4 wheels. 4 wheels is common, right? There will the client will not come and say that you develop a car and the car should have 4 wheels. The car shape should be like this. So all these things will not be done by the client. Will not be told you by the client. Why? Because those are all the non-functional things. Those are the basic things that should be added, right? And coming to your software also, if you are asked to develop a library project, for example, the library project will include different functionalities, different modules which perform different functionality. For suppose if you are having a renewal module, book renewal module, that functionality will be, you should be able to renew the book, right? Payment module, if you are having any due dates or anything, that module should function in such a way that the fine should be calculated automatically, right? Book issue module, the functionality will be different. Book return module, the functionality will be different. So all these are the basic functions that module should perform. So all this comes under functional requirements. When coming to non-functional requirements, if I'm asking you to develop a library project, I'll not be asking you saying you that this only the admin should be able to log in. For example, security feature. I'll not give you in detail in separate and ask you that this security feature should be provided. See, only the admin should be able to log in into that website. That is the basic function. That is the basic thing any project should contain, right? I'll not specify you in detail saying that only the admin should be able to log in into the main account. Sir, that is the basic thing you should involve. And I'll not be saying you that it should be usable or easy for me to use, right? It's your task to develop a project web page in such a way that I should be able to use it. It should be friendly. It should be in a friendly environment too. It should be easy for me to use that website, right? That is non-functional things. So that will not, those are the basic things that are involved, right? Usability, portability, security, good looking, all these are non-functional things which will be common for all the projects, right? So here we'll be seeing about this, all these things in detail. So what we are saying here is, in this requirement modeling, we'll be preparing a software requirement specification document. That document contains what are all the things that should be included in our project. It can be either functional requirements, it can be either non-functional requirements, it can be either software requirements, hardware requirements, environment requirements, platforms, process, all these things will be written in the software requirements document. Now this document is moved on to the next phase, given to the next phase. Here you will be preparing the architectural design. Design is nothing but modeling. As we already told you, diagrams as per your C language, flow charts are prepared. Seeing this planning document, seeing that document and analyzing this document, you will be preparing a model here. Diagrams will be prepared. Here we are saying architectural design and component design separately. Architectural design is the model for the entire system, the complete project you are going to develop. If you are preparing this design for the complete system, that is called as architecture design. Here high level designs will be prepared. In the sense, we'll not go into in detail in narrow part. Here, the high level design includes the platform you are using, the hardware, software, all the module, all the design of the complete system. How the design should look like overall, how the architecture of the system should look like, right? I'm not going into a module part. I'm just saying that how the overall system should look like. If you are preparing a design of that complete architecture, you will call it as a high level design here. And next is the component design. Here you will go into in detail part. Here I am saying the library management system contains these pages. This website, from this website it is going to connect to this server part, this CRR server part, and from that server you will be given the data. So I am giving the overall picture, overall the architecture of the complete system. But here in the component design, I'll go in detail into all the modules. So in library management system, these are the modules that should be included. The renewal model design should be like this. The payment module design should be like this. So right, the billing module design should be like this. Each component design should be like this. Component is nothing but small modules. Every individual module designs will be prepared in this design part, right? And next, after the module design is over, we'll move on to the coding part where the code is generated. See, right, this is all what is done, all the phases which you already know, and what is done in this half part of the V model. See, right, again going back, while you are preparing a software requirement document, parallelly you will also prepare a plan for acceptance testing. So right, acceptance testing is done by the end user, by the client, right? While you are preparing this document, you will also parallelly prepare some test cases, right? By which you'll check whether the client will be able to satisfy finally or not. You are preparing the test cases parallelly. And while preparing the architecture design, you will be writing the test cases for system design, system testing. And while preparing the component design, you will be writing the test cases for integration testing. And while writing code generation, you will be writing the test cases for unit testing. So parallelly, in each phase, you are parallelly preparing some testing documents, right? And after preparing the testing documents, see, after now coming here, you generated the code and the code is ready now. Executable software is ready now. After the executable software is ready, so you can't deploy it to the client, right? Now you need to perform testing. While performing testing, while code generation itself, you have planned how to perform unit testing. While writing the code generation only, you planned. Remember, I am saying you have already planned how to perform unit testing. You'll take all those test cases and perform the unit testing here. You'll check the addition module in arithmetic operation program. You'll check the addition module. You'll check the subtraction module. You'll check the multiplication module. You have already planned what to check in addition module. For example, if you are taking addition module, you wrote a test case that you will take two numbers as input. For suppose 2 and 3 as input. Input will be 2 and 3. Output that should be produced by that module is 5. You have already written the test cases, planned the test cases initially. Now you will check the test case. You will give the input as 2 and 3 for that module. You will check whether the output is coming as 5 or not. If it is 5, then you will say that the test case is passed. If you are getting any other output other than 5, you will say that the test case is failed, right? Similarly, you will check for subtraction. Similarly, you will check for multiplication. So every individual unit or module is tested here, right? And next, after the unit testing is over, now you'll come to integration testing. While designing the component design, while preparing the models in the component design, then only you have planned how to for your integration testing. So all those documents will be taken, that planning document will be taken, and the testing will be performed here. Integration testing will be performed here. In the sense, when you are combining addition and subtraction module, you'll check whether you are getting any error or not. Whether and next, these two modules with multiplication, you are checking whether you are getting any error or not. These three modules with division, you are checking any error or not. So you are checking whether you are getting any errors while integrating the modules, which is previously planned already, right? And next, coming to system testing, while preparing the design for the complete system, complete architecture, then you have already planned what to test in system testing. Now you'll take those test cases and test accordingly. So this is called system testing. You're testing the complete system again, complete project again, complete arithmetic operations and a program ni complete ga malli check chestunaru, complete library and a project ni complete ga check chestunaru. So that is called as system testing. So you're taking the planned document from here, test cases here, and you're checking whether they're running properly or not. Next, after system testing, you will be having acceptance testing. I already told you in the last class, in the system testing, we'll be having different types of testings: alpha testing, beta testing, and next acceptance testing. Alpha testing is done by the developers. Whoever has developed this project, they will be testing the complete system. That is called as alpha testing. Beta testing is tested by the friendly customers, or you see most of the softwares initially, before releasing the product into the market, they'll first release the beta version. So it is asking the users to check that product and give them feedback. For suppose if you are giving any feedback, if you are giving any feedback like this extra feature can be included in this, or this feature is difficult for you, this module is difficult for you to run, all the feedback is taken from the client, and again all the changes will be done in that product, and finally the product will be released into the market. So before the main product is released, beta version of the product will be released into the market. So you are just asked to test in a friendly environment, right? So that is called as system testing, alpha testing, and beta testing. And finally, coming to acceptance testing, while preparing the SRS document document itself, you have planned what the client wants. You know what the client wants finally, and you have written the test cases. If those test cases are passed, you can conclude that the client has been satisfied, right? So those planned test cases will be tested here. That is called as acceptance testing, which is done by the client. So this is the architecture for V model, students. It's very simple. As in the previous phases only, we saw already, all those phases are written here until code generation. All this is called as verification phases. So model requirements are gathered, SRS document is prepared. While preparing the SRS document, acceptance testing is planned. In the right, test cases are written to check finally whether the client will be satisfied or not. Here we have just planned, we have not checked, right? We have just prepared the document. We have just prepared the question paper here. Think that you have just prepared the question paper. What are all the questions that will be asked while performing the acceptance testing, right? And next we moved on to architectural design. The complete designs for the complete system is done here, and we have prepared the question paper for the complete system, right? And next, component design. Each module is designed here, and we have prepared the questions for each module. And next, code generation is done here, and finally the executable code is ready, right? And now again moving upwards. While moving upwards, here you have prepared the question paper to check each individual module, right? That module will be tested here now. Now unit testing is performed here. Here you have prepared the question paper for each individual. So here for code, here for module. Integration testing is done here. You'll take the question paper from here and perform the system testing. You'll take the question paper from here and perform acceptance testing. This is what is done in V model, right? So the main extra feature when compared to waterfall model here is you are involving different testing phases. Planning of different testing is done initially. That is only the extra feature which is included other than waterfall model in V model. Coming to these advantages and disadvantages, you'll be having the same advantages as in waterfall model. It is simple and easy to understand. Same as waterfall model, this V model will only be suitable for small projects where the requirements is clearly understood. See, the requirements should be given in the initial phase itself. We are not taking the requirements in any other phases. So the client should give all the requirements in the initial phase itself, same as waterfall model. But the only difference is planning of the testing is done in each phases. That is the only variation in V model when compared to waterfall model. And coming to disadvantages, same as waterfall model, this will not be good for complex and object-oriented projects. For complex projects or risky projects or object-oriented projects, this will not be suitable. This V model will not be suitable. And no working software is produced until late during the life cycle. See, until the software development life cycle, only here the working product is developed. Executable code is developed only in this phase. We have no idea of all the working products in any other phases, right? So this is the same drawback as in waterfall model. The advantages and disadvantages for waterfall and V model will be very much similar, right? You'll be having the same thing. So this is the another model of SDLC, software development life cycle. We saw first waterfall model and next we saw V model. Both these models comes under linear model. And next is iterative model. So iterative model combines the elements of linear and parallel process flow. So you saw what is linear flow. All the activities will be, all the 5 framework activities will be done one after the another. You saw what is parallel process flow. These framework activities can be done in parallel. So iterative model combines both this linear and parallel process flow. So right. So here if you are having a situation where the client is giving you some project, he is expecting you to release that project immediately. That client wants that working product within short time, right? He just gave you some very short deadline and he's asking you to release that project within that short deadline. So you know that you'll not be able to complete that project within the deadline, but you want to release it. In that case, what we'll do is, first of all, you gather all the requirements from the client. You take all the requirements which the client wants, but you try to develop the project in different parts, in different modules, so in different versions, right? But the requirement gathering should be done initially. You'll take all the requirements from the client initially. You'll plan how this product will be, how this product can be released in different versions. In the first phase, the main version, the main functionalities will be released first, and the next phase, new functionalities will be added to the older product, and again it will be released in the next phase, and it will be continued finally until the client gets satisfied. So that is called as incremental model. If you see the diagram, you'll understand it clearly. See here, the incremental model, see this is the diagram. See this is the 5 framework activities. These are the 5 framework activities. You know, prime activities are communication, planning, modeling, construction, deployment. This is communication, planning, modeling, construction, and deployment. The 5 framework activities, what we have done here is, you have gathered all the requirements from the user initially. And in the first increment, what you have released is, you have delivered only the first increment version of that product. You have not completed the product completely. You have developed some part of the product, took some requirements, basic main requirements. You planned according to those requirements. You started modeling, you started coding, and finally gave the version to the client. The first increment is released, right? Now, after releasing the first increment, now you'll plan for the second increment. Whatever features that are not included in this first version will be added in this second version. Again, this product is already released to the client, right? He'll be able to see that software. He'll be giving you some feedback, right? He wants some other thing to be included. So all those things will be considered for the second increment release. Feedback taken from the client, and also as per the requirements that we have planned initially, all those requirements will be taken in the second increment. Again, the product will be released, right? Again, feedback will be given. Again, third increment will release, fourth increment, until n number of increments. This nth increment is where the client is finally satisfied, where the acceptance testing is done, where the client is finally fulfilled and it's enough to end that project. So until then, n number of increments will be released into the market. So this is called as incremental model. So this model will be suitable for larger project. Why? Because we are not releasing all the product at once. We are only releasing some small module at once, right? See, now coming to the theory part, when an incremental model is used, the first increment is often called as core product. So the increment that is released here is called the core product, the main product, right? What this core product is, that is the basic requirements are addressed, but many supplementary features still remain undelivered. While releasing this core product, the basic requirements are addressed and the product is released. So suppose if it is a car development, while releasing this first feature, basically the car is released and the basic functionalities of that car will be going on. In the sense that car will be running on the road, it will stop when the brake is applied. all horn will be functioning. All these basic functionalities will be included, and then the product is released. When coming to next increment, apart from these basic requirements, new extra features will be added, like some Bluetooth will be included in car, or some other extra features, automatic maybe automatic key locking or automatic all this will AC, all this will be included in some extra features will be added in and released into, again some extra features will be added and released into the market. So this is what is done. So that is what we are saying here. In the basic requirements, in the first release, that is the core product, the basic requirements are addressed and released, but the supplementary features remain undelivered, right? The core product is used by the customer. As a result of new evolution, a plan is developed for the next iteration. This core product is given to the customer, he'll be using it. And if any feedback is there, that is taken from the customer. And as we have already planned previously, as the developer has already planned previously, the next increment will be carried on. So this will be continued in an iterative way, right? The plan addresses the modification of the core product to better meet the needs of the customer and the delivery of the additional features and functionalities. So this is what we are keeping on telling repeatedly. In the next features, in the next version, another feature, another functionality will be added, another features will be added, and so on, right? For example, in our software, if you have noticed while you are in schooling or some other thing, maybe you have already seen MS Word, Microsoft MS Word document, right? When this MS Word was released initially, what that document contained is, it only contained basic file managements, how to write a letter, basic things, how to write a letter, editing, some editing features are included in that Word document, and some document production functions in the first increment. As per my knowledge, MS Word 2003, that is the basic document that was released first. That 2003 version contains all these only basic file management activities, basic thing, basic editing, basic functions, right? And next, when 2007 version was released, apart from these basic things, some sophisticated editing and document production capabilities are also released in the second version. So in addition to this basic things, some other new features are added, and the second version was released. And in the third version, spelling and grammar. Now, if you see, if you are typing anything in the Word document, if you are writing any spelling wrong, then it will be indicating you in a red mark. It will be warning you in a red mark, right? If you right click, the correct spelling will automatically be replaced, right? So this is a new feature added in the next versions. Initially, when they have released the Word document, all these features are not added, right? In the next version, the spelling, grammar checking, all these are incremented. And in the next version, advanced page layouts, all the page layouts settings, all the color versions, font versions, all these advanced things are added in the later version. And this keeps on continuing, right? And maybe in some other next version, some other new features will be added. So this is the example of software which you all the people know, MS Word document, right? So this can be an example of incremental model. So right, and coming to the advantages of this incremental model, this incremental model are able to generate working software quickly and early during the software lifecycle. See, we told the advantage in disadvantage in waterfall model, that the client should wait until the end for long amount of time to know what was the working product, what was the project that has been developed. But here in incremental model, a small versions of the product is released, right? All the time some small versions of the product is released. So in the within short amount of the time, the client will be able to see the project. He'll know what the project contains. Maybe not all the advanced features are added, but he'll be able to see the project initially where the basic functionalities are added, right? In the sense, the client will be satisfied, right? That is what we are saying here. The working software is seen by the client quickly during the early software lifecycle itself, right? This model gives a large initial capital outlay with the subsequent long wait avoided. So there is no need for the client to wait for long amount of time. The initial outlay is seen by the client initially, right? Within short time only, the client will be able to see the output of that project. The model of development also helps ease for dramatic effect of introducing completely new system all at once. See, the client will not wait for long amount of time and finally see that complex project. He'll be able to see the projects within short amount of time. So all these points are giving us the same meaning, right? The client will not wait for long amount of time to see the deadly project output, right? He will be able to get the output in initial stages itself. So these are the advantages of incremental model. And coming to disadvantages, to perform this incremental model, first of all, we should be able to divide the large project into different modules, right? Different increments, in the sense that the incremental model approach required good planning and design expertise team members. So only the experts in that area will be able to plan what to release first, what are the basic functionality, which version should be released first, and what requirements can be included in next feature and what can be included in next feature. Only an expertise person will be able to plan all this correctly, right? So only experts are needed in this area. And next, it requires complete task and full functional requirements with the product in the requirement analysis phase that take high amount of time. The total cost of the system is higher than the waterfall model of the software. So as you already know, so we are keeping on releasing the project, right? Maybe this can be continued for a large number of years. So definitely the total cost will be increasing. So right, total time will be taken more. If time is taking more, if you are taking much time, definitely the cost will be increased, right? That is the another disadvantage we are saying. And first of all, you should have a clear requirement analysis here. The client should be giving all you the main requirements. You should be able to analyze all the requirements, and you should be able to plan what to do in first requirement, what to release in first requirements, what to do in second, and so a clear expertise persons are needed to do this model, right? So these are the advantages and disadvantages of incremental model. Hope you understood. Yeah. Next, coming to evolutionary process models, we'll continue this in next class. So yeah, are you having any doubts? So the basic things we saw in this class is, these are important concepts, students. In prescriptive models, please note down, in prescriptive models, first model is linear model. In linear model, first model is linear model. In linear model, we saw three models. In linear model, first one is waterfall model. In linear model, second one is V model. In linear model, third one is incremental model. All these three models comes under linear model. So right, this is the waterfall model we saw. This is having some disadvantages, like test plan is not done initially in waterfall model. To overcome that, we came to V model where test plan is done initially, right? These are having some advantages, and it is having some disadvantage that the client needs to wait until a long time to get the working product. He need to wait for much amount of time to get that working product. This is the main disadvantage here. To overcome this disadvantage, we moved on to the next linear model called incremental model, where the client is not needed to wait for long time. That small version increment release is given to the client initially itself, wherein the client will be satisfied. So from here, we'll move on to the next version. So those are evolutionary process models. In evolutionary process, we'll be seeing prototyping, we'll be seeing spiral model. So until today's class, we have completed linear process models. So are you having any doubts? So students, are you having any doubts? And number 42, A sections here, number 42. A sections here, please respond.
Ma'am,
Number 42, ask him.
42.
Ask him